G'day guys, we've got a integration question for you today where we're asked to find the area enclosed between the curves y equals x and y equals 2x cubed on x squared plus 4. Now we're told that these two curves intersect at the origin and x equals 2. Now I'm going to go about this problem in two very different ways, and the reason I'm going to do that is almost to highlight the importance of developing a robust mathematical repertoire of tools to make problems like this a lot more easy to handle or easy to manage in exam style situations. So in order to find the area enclosed between these two curves, we're going to have to integrate the vertical distance between the two curves between 0 or the origin and where they intersect again at x equals 2. Now the way that we integrate the vertical distance between them is that we're going to take the definite integral from 0 to 2 of the top function, or y equals x, subtract the bottom function, which is this 2x cubed over x squared plus 4. So whenever we have an integral that looks like this, I always think it's a good idea to split up the integral into its parts. And so I'm going to rewrite this integral as the definite integral from 0 to 2 of x dx minus the definite integral from 0 to 2 of 2x cubed over x squared plus 4 dx. Now from here, guys, the integral of this linear function is not going to be very hard for us to do, so I'm going to leave that to later. I want to first start by focusing on the definite integral of this particular function here from 0 to 2. So there are two main ways that we can go about this. We can essentially separate the fraction up and then integrate the parts of the fraction, or we can use what's called a substitution, and basically a substitution works by reversing the chain rule of differentiation. So for this particular integral here, guys, what I'm going to do is substitute the denominator. So my first substitution that I'm going to make is I'm going to say let u be equal to x squared plus 4. Now what I'm going to have to also do is come up with a substitute for this dx here. So to get that substitute for the dx, I'm going to differentiate u with respect to x. So du dx will be equal to 2x. And as a result, I can say that du is going to be equal to 2x dx. Great. So the next very important step of the substitution method is adjusting our bounds of integration to essentially match what our substitutions are. So the bounds of integration on this particular integral here are for x. We need to make them for u. So because we know that u equals x squared plus 4, that's what our substitution is going to be, we can say that when x is going to be equal to 0, u is going to be equal to 0 squared plus 4, or 4. And when x is equal to 2, u is going to be equal to 2 squared plus 4, which is 8. So essentially, guys, when I write down my integral here from 0 to 2 of 2x cubed over x squared plus 4 dx, this is going to be able to be rewritten as the integral, if we're going to start using u, from, rather than writing 0, I'm going to write 4 to 8. So my first substitution is the x squared plus 4. I'm going to substitute it with u. Also put the stuff we haven't substituted in a different color. We have this 2x cubed in the numerator, and we also have this dx. Now, what we can do to deal with this dx is I need to rearrange the numerator here so I can essentially take out a 2x outside of the quotient. So I can rewrite this as the integral from 4 to 8 of, now let's just put the denominator in again. We've got u. I'm going to take a 2x out of the numerator. So I'm going to write 2x dx out here, and 2x times x squared is equal to 2x cubed. Now what I can then do is I can substitute that into there. So I'm going to then rewrite this as the integral from 4 to 8. Again, we're going to put our denominator in first. Now we have this 2x dx is actually equal to du. And what I'm going to do with this x squared is, if we have x squared plus 4 is equal to u, well, this can also be rearranged to say that x squared is going to be equal to u subtract 4. So what I can do is, rather than writing x squared in the numerator, I'm going to say u subtract 4. And now guys, what I've been able to do is take this relatively or really complicated integral, and using a substitution, I can change the bounds of integration and present it as an integral which is essentially quite easy to solve. So to solve this integral, I'm going to first split the numerator by going the integral of 4 to 8 of u over u minus 4 over u du. Now, we can rewrite the integral of u over u as this is just going to be the integral of 1. So from here, we can actually start evaluating the integrals. So the first one, the integral of 1 in terms of u, is going to be just u, and we're going to evaluate that between 4 and 8, and after that we're going to subtract the integral of this, which is just 4 ln u, evaluated from 4 to 8. Great, so let's start taking this integral. This first one here is simply 8 subtract 4 minus 4 ln 8 minus 4 ln 4. So pretty self-explanatory. 8 take 4 is 4. This one might not be as self-explanatory. I can factorize by 4 and say this is ln 8 minus ln 4, which is equal to 4 minus 4 ln 8 over 4, which is equal to 4 minus 4 ln 2. So we have found that this 4 minus 4 ln 2 is the integral to this. So we're also going to have to work out what the integral of this linear function is. So we've got the integral of 0 to 2x dx is going to be equal to, well, the integral of x is going to be x squared on 2 from 0 to 2, which is equal to 4 over 2, which is 2 minus 0. Great. So finally, guys, we have the integral of this one now. So just for the sake of clarity, let's write down the full solution. So the area entrapped between the curves is going to be equal to the integral from 0 to 2 of x dx minus the integral from 0 to 2 of 2x cubed on x squared plus 4 dx, which we found was equal to 2 minus this value here. So this is going to be equal to a minus, and a minus is going to make it positive 4 ln 2, and 2 take 4 is negative 2. Now, when the question asks for area, we have to make sure that unless we're told otherwise, we write afterwards units squared. So the next way I'm going to go about doing exactly the same problem, guys, is rather than using a u-substitution or the substitution method, I'm going to instead attempt to simplify this quotient here by using algebraic long division to divide 2x cubed by x squared plus 4. I'm going to set it up like this. 2x cubed, and I'm trying to divide this by x squared plus 4. So if you guys aren't acquainted with algebraic long division, let me go through it quite quickly with you. So the first step is we're going to go 2x cubed divided by x squared, and that will come out to 2x. The next step is that we go 2x times x squared is going to be 2x cubed, and then we have 2x times 4 is 8x. Then what we do is we subtract the second line from the first line. So we're going to get 2x cubed take 2x cubed is 0. And then nothing take 8x is going to be minus 8x. Now there's nothing else to bring down. So we can essentially say that x squared plus 4 goes into 2x cubed 2x times with negative 8x remainder. So how does that functionally work out in this scenario? I can say that the area enclosed between the two curves is going to be 0 to 2 of x, that stays where it is, minus, now let's just put a bracket to separate them. We're going to have 2x minus 8x over x squared plus 4 dx. So for those of you who are wondering really how I got from this to this, let me go through a non-algebraic example. Let's say that I have 673 and I'm going to divide it by 5 using long division. So the first thing we do is we go, well, 6 divided by 5 is 1. I then go 1 times 5 is 5. 6 take 5 is 1, and I bring down the 7. I then go 17 divided by 5 is 3, and then I'm going to go 3 times 5 is 15. I then do the subtraction, and I get 2. I then bring down the 3, and I go 23 divided by 5 is 4. And then I'm going to go 4 times 5 is 20. Do the subtraction, and I'm left with 3. Now, there are no more numbers to bring down, just like there were no more numbers here to bring down. So what I can say is that 673 divided by 5 is equal to 134 plus 3, which is my remainder, over 5. And that's the same here. 2x cubed divided by x squared plus 4. Well, it goes evenly 2x number of times, which is here. So that 2x is the equivalent to the 134, the even amount of times it goes in. And then it has a remainder here of negative 8x. So the negative 8x, the remainder, which doesn't go evenly, is then divided by the denominator, which is what we did here as well. The remainder was 3, which we then divided by 5. So we divide the negative 8x by the original denominator, and that's how we end up with this part. So from here, guys, I'm going to rearrange my integral. So I'm going to call it the definite integral from 0 to 2. Now, I'm going to go x minus 2x will end up being negative x. And we've got this minus 8x over x squared plus 4. But minus minus will turn that into a positive. So I'm going to begin with that part. So we're going to have 8x over x squared plus 4 minus x dx. Now, just for clarity, guys, let's split this integral. So we have the area is equal to the integral from 0 to 2 of 8x over x squared plus 4 dx minus 0 to 2 of x dx. Now, so when trying to evaluate this particular integral here, guys, I'm going to recognize that the derivative of the natural log of x squared plus 4 is equal to 2x over x squared plus 4. Now, what I'm going to use this for is because this looks awfully similar to this. So my thought process is factorize out a part of this coefficient to ensure that this quotient looks like this. So from here, I can say that the area is equal to, let's take a 4 out the front, 0 to 2 of this, minus 0 to 2 of x dx. Now, from here, guys, you can see using the fundamental theorem of calculus that if I was to take the integral of both sides, if I integrate it, the integrals and the derivatives would cancel, and I would be left with the area is equal to 4 times ln of x squared plus 4 evaluated between 0 and 2. Now this one here, similar to the u that we had in the previous problem, is going to be equal to x squared divided by 2 evaluated between 0 and 2. Now this is going to be equal to 4 times ln of, when I sub in the 2, it's 2 squared, which is 4 plus 4 is 8, minus ln of 4, minus 2 squared is 4 on 2 is 2, minus 0 on 2 is 0. Now this is equal to 4 ln of, you guys can see some similarities hopefully from the last one, and this is just equal to 4 ln 2 minus 2. And you just have to remember that you put your units squared to ensure that the marker knows that you have found an area which is enclosed between two curves.